Okay, day 4, trig identities. Day 4. No new identities for today, but we are just trying another methodology to solve our trig identities. So let's say we have cosecant squared of theta minus cosine squared of theta times cosecant squared of theta. And we want to set that, prove it equals 1. So let's go through our processes. Okay, I see we have a cosecant and a cosecant in the first and the second term. I'm going to factor that out. I'm going to factor it out. So if I factor it out, I get cosecant squared of theta. This is 1 minus cosine squared of theta. Okay, 1 minus cosine squared of theta, I know for sure is sine of theta. Remember from our Pythagorean trig identities, sine squared of theta plus cosine squared of theta equals 1. So 1 minus cosine squared of theta must equal sine of theta, sine squared of theta. So this is cosecant squared of theta times sine squared of theta. Well, let's change cosecant. Isn't cosecant the inverse of sine? So cosecant is 1 over sine squared of theta times sine squared of theta. Well, then they simplify to reduce to 1. So then our answer is just 1. Let's do another example. Let's say I have a secant square, just a secant of theta minus cosine of theta over secant of theta, and I want to prove this equals sine squared of theta. But let me simplify this left to solve it. I can split this up currently, right? I can split this up. I know this is secant of theta over secant of theta, and split this up into 2 fractions, cosine of theta over secant of theta. And my secant of secant reduces to make 1. I can change my cosecant of theta. I can change my secant of theta. Isn't that the inverse of cosine? So my secant is actually cosine of theta. So 1 over secant of theta is actually cosine of theta. And this becomes 1 minus cosine squared of theta. And as we know, 1 minus cosine squared of theta is sine square of theta, verifying this identity.